Okay.
On that note, it is my great pleasure to introduce Ervin Ruci, who will be speaking about GeoParser text. Whenever you're ready.
Excuse me, I've lost a little bit of my voice, but I hope you can hear me fine. I'm going to talk about a topic, an old problem that has been researched quite a bit, but a new iteration of that. Geoparsing. Who is familiar with geoparsing? Yeah. Okay. Okay. So let's come back here. Oh. So now you know. Oh, wait. Is it stuck? So yeah, about this talk, I gave the first version of this talk at the FOSDEM in January at the JoeParr dev room, and some members of the audience were really surprised that I was using Perl. One of them actually said, well, it's 2016. Yes, I know. Perl is still great for solving problems such as this one, especially with text processing. So I've expanded a little bit the talk, and I've also written a cpan module to interface with the API, which is a Perl service running at Geocode XYZ. So here is the problem. Let's say we have a text like this, and how many in the audience who haven't already seen my slides, which were posted, know how many locations are in this text? 6? 2? No, there is 6. Those streets actually exist. I found them while testing this, because I'm not very imaginative and just write this street, that street, and actually they came up. The data I use is all from OpenStreetMap and open addresses, and here is a more detailed response that the program gives you, because that sentence is short in itself, but it has a lot of information. As the software scans through it, it can find a lot of information, and they are all valid answers. There's also sometimes that there's ambiguities, but I'll get to that later. So the requirements for this system are to identify addresses, intersections, city names, and province state on any kind of text. The solution is pretty much described by this flowchart. You have some input string. It goes through a named entity recognition engine, which extracts from it the tokens that have to do with locations. And afterwards, it's geocoded. It could be done either in batch or one at a time. And the result is stored. Geocoding is a process that actually spans many fields, especially since you're dealing with text written in different languages. So linguistics is one topic. The other one is data processing. We're dealing with a lot of data. Right now, OpenStreetMap has 3.2 billion nodes, and extracting all that information, putting it into a data structure for fast access and so forth. So, involves a lot of that process. Standardization as well is another topic. Natural language processing obviously is the key here. Parsing is one of the keywords. You need to be able to extract only the information that you need from text and then match it to your database. There is some computational geometry. Usually, when you're trying to deal with ambiguities, you can do some clustering. You can figure out if this polygon of this city has this point inside or outside, things like that. And then you have pattern recognition for fuzzy addresses, mistyped addresses. There is geography as well, especially when you import data from various projections. Artificial intelligence, which I have implemented in the latest version that I'm building now. I'll tell you a little bit more about that. And a lot of testing, of course. So, why go into all this trouble? You might ask, why would I work on this problem when Google has already done it? And many people think it's the best. I have tested them, actually. Nobody is at 100%. This is the problem with geocoding. And there is even startups right now who are trying to invent a whole new system of addressing. Like, have you ever heard of where 3 words? You have? So basically, where 3 words is a system that they assign 3 random words to each latitude and longitude pair, and then you find location like that. Because it's really tough to geocode location written in human language, especially in areas where addressing systems are not very well developed, like in the third world, for example. So this is a problem even for Google and their competitors, various competitors. Nominatim is the OpenStreetMap geocoder, actually is the worst from my testing of the whole bunch. And MapZen is a new company that is also released an open source geocoder, and you can test it yourself. The results are given at that link there. So Google Geocoder even doesn't provide 100% coverage. It's an open problem, and so is 100% accuracy. But there's other things as well. They don't bother, for example, with parcel data. You know what parcel data is? Just, let's say, in Alberta, they have a system called legal land descriptors, and they have every parcel of land in Alberta described this way. But these are government-produced data. Not many people in the general public would use it, but researchers would find that useful. And Google doesn't do geoparsing. So if you copy and paste a page from Wikipedia into Google, you will not get what you're looking for. So my problem is I want to throw in text and I want to extract all locations from this text. And doesn't do a lot of standardization. There is a problem, for example, in Canada, it only gives 3 letters of the postal code, not the full postal code. And provides limited, doesn't provide limited API access. Like Google has, I think, 2,500 requests per day that it allows you to make. So there is many reasons why create a new geocoder, and those are only some of them. So how to go about it? You need 2 things, data and a good parser. I think data is the biggest challenge, but recent years have shown that open data movement is gaining steam, and there is a lot of data now. When I first started working on this problem, it was when I was a grad student about 12 years ago. And back then, it was really a pain to obtain any good data. Right now, you have a lot more options. And then it's the algorithm, the parser. The parser is the key. So, and parsing itself, there's more than that. There's also fuzzing and exact parsing, and then you have to figure out a confidence score on your response. You have to know if it is, you can tell the user that this is a result with high confidence, low confidence. You can show them that this is a partial, complete parsing result, because the parser has to be able to fill in missing location entities. Sometimes people just write the NYC or HFX for Halifax, for example. Things like that all have to be taken into consideration. How am I doing for time? 12 minutes. Oh, I'm doing great. So this is like, oh, it opens here. This is just a quick example. Am I click that? Okay. So let's say if I type Orlando. In this case, it should find all Orlandos that exist around. Obviously, it's not very descriptive. If I type Orange Street, I don't know, Orlando. I don't know Orlando very well. I just passed by this. I like this name, Orange. So now, a little bit better. As you can see there is 3 results. Orange Avenue North, and then there is one with a number. And that's the number that is closest to that location. Because you have no numbers in this, the parser assumes that it has to give you back a number. And it could also be an intersection. There could be Orange Street East and Orange Avenue North, Orlando, Florida. So although you gave it incomplete information, you get back complete information and standardized as well. So let's go back to, I can go on and on this. The thing is, the more information you give the parser, the more responses you're going to get back. Sometimes more, sometimes less. If you're more specific, you're going to get more specific answers. If you're less, then you get, so that's up to you. But this is an imprecise process, and there is various errors. Okay, halfway, great. How many slides? 12 out of 13. These are short slides. So there's a lot of ambiguities and complete data, incorrect data, software bugs. Have you heard of openaddresses.io? This is a project I'm really fond of. They started only 1 year ago. And when I started, they had almost 100,000 addresses. Now, actually, there's more than that number there. There's almost 260 million addresses across the world. And they are free and open to use for anyone. And obviously, there is OpenStreetMap, but OpenStreetMap has incomplete coverage in various areas, so Open Addresses fills that void. These are the data I'm using right now. Because as I said, even Google Map fails. And you have probably heard, like, this is close to where I live in Ottawa. There was a news story about Google Maps sending fire crews to the wrong address and some dogs dying in the fire. So that's why I would call it a Google tragedy. Well, even here in America, there's a case of a wrong house being demolished due to Google Maps sending the crews to that house. So like I'm saying, nobody can really get this 100%. It's a fact of life. You have to keep working on it. And even if you Google wrong location, you get wrong location on Google Maps. That also is a testament of their popularity. But just to say that geocoding and geoparsing in a structured test is an interesting problem, and it's an open problem that many people can take a stab at it. Right now, I am rebuilding the whole process. Like, I started this 12 years ago, but 8 months ago, I decided I want to rewrite it in Perl 5 again. I'm not ready for Perl 6 yet. But so I'm rewriting, I'm learning from my mistakes, and there's this new website that I'm doing here. It's called Geocode XYZ. As you can see, it's a nicer interface than the other one. And I use some Bootstrap. I'm a terrible designer, but basically it's the same thing. Like, I copied and pasted some text from Wikipedia there about Vienna or Austria, and then you'll get your responses here. So this is GeoParser, batch geocoder, and geocoder, and it's a free API, so it's unlimited. You can test it, you can do whatever you want with it. This is a CPAN module I wrote. Eventually, it will only use Geocode XYZ, because that will be the one that will merge all my projects, and it will have worldwide coverage. Right now, for North America, is geocoder.ca that is offering that coverage, and for Europe is Geocode XYZ. And for Australia, it will be another one. So basically, you call it like that. It's pretty simple, and you get a response like that. And here's a couple of other applications I've been working on. One of my favorite is this one, is Open Wikimap. Okay. So Open Wikimap aims to put Wikipedia on OpenStreetMap. So basically, it scans all of Wikipedia. And these are some Wikipedia pages, I guess, here. I say what that is. Oh. I can hardly see here. So let's find like a big cluster somewhere. Is there Berlin there? Because I like Berlin. Berlin has a lot of nice examples. Is that Berlin? Here? Leipzig. Oh, Leipzig is good too. I need a big city with a lot of data. Oh, come on. There you go. So basically, you have all the matches here. Oh, come on. I'm just clicking at random until I find, okay, this is, so let's say it's found something there. Called out, let's see, and it shows you where in the text, somewhere in the context of that page, it found that information. So what I'm doing is I've written a crawler that crawls Wikipedia, Wiki Travel, and all the wiki pages. But you can add your own. You can add your own pages to crawl here. You just give another URL, and the crawler will take that as well. So this will grow as the time goes by, and the goal is to put all the world's information on a map, scanning it and putting it there. But not only that, you could also do. I was also worrying about the internet quality, but this is great. This is the United States. I've had some problems in other places. So basically, you can scan Twitter on real time. And not all tweets have lat long with them, are geotagged. So you have to do it yourself. And if you scan it, then you get something like that. These are all like various slides that demonstrate what I already showed you. So the challenge is that, to make it accurate and to make it as complete as possible. These are various processes that I employ along the way. And here comes Perl, that makes easy problems very easy and hard ones easy. So, like I said during my other talk, no other language is better at slicing and dicing text. And there's a lot of things on JoeParr that I have used for my project. And that's it. Thank you very much. Go ahead.
Are those slides going to be available somewhere? Because all those URLs you flew through are
Oh yeah, it is on my Twitter feed. I just posted it there.
wonderful, thank you.
Geocoding. And it's also, I think it's also on the conference website.
Oh, great.
Yeah. Yeah, the question?